So now students, uh, when we have discrete objects like m1, m2, m3, so the mass is m1, m2, m3, so we write there the coordinates of the center of mass as this way. Now, and to summing it up, how we will be writing? Sigma mi xi upon sigma mi, right? And this as sigma mi yi divided by sigma mi, right? Now turn on the page and page 146. Now suppose instead of these discrete discrete objects, means these countable objects, you have the extended body. So a lot of particles, you cannot means lots and lots of particles are there in the body, so you cannot write them in this way. So how we are going to write it? What is the method that we are going to write it? So I am going to read from page 146. We subdivide the body into n small elements of masses. So what you are going to do? I am dividing this body into small masses, okay? Small masses. So this is suppose this is so mass of this small element is m1, mass of this small element is delta m2. So delta means we use for the change also, and we use for the small. So delta is for change also, final minus initial, and delta also we use for small, very small, okay? So two ways. So delta m1 and this is delta m3. So now we have subdivided the body into n small elements, delta m1 and delta m2 and up to delta ms. So this can be any piece here. So suppose this is delta mn, okay? Let it be ith particle, ith. And what is the difference between n and I? I means any particle, any particle. It can be any particle from 1, 2, 3, so on, and n is the last particle. Last particle, okay, and up to n. So ith particle means any arbitrary particle, particle 1, 2, 3, 4, any, it can be any particle, and we use n for the last particle, okay? So here, because the particles are infinite, so I cannot say any particle as nth particle, so that is why delta mi. So what are the coordinates of the center of mass? So coordinates of the center of mass, x will be equals to, so the coordinate means, so coordinates are of course center of mass coordinates are x, y. So what is x here? X coordinate is, I can write it as similarly in this way, sigma mi xi. So what is the mass? Sigma mi, and there can be n particle also, so sigma mi xi divided by sigma delta mi. So instead of writing mi, because here the mass is very small, I am writing delta only. So that's the only difference. So there is no difference, students. Is it okay? And y equals to sigma delta mi yi. So simply I am replacing m with mi with delta mi. This is the only thing I am doing, okay? Divided by sigma delta mi. And if there are z coordinates also, then they will be sigma delta mi upon sigma delta my zi upon sigma delta mi. Is this okay, students? We are comfortable with this? But now the thing is that we are making, what we are doing now, we are making n bigger and bigger. So make, because see, what are the coordinates of m1 x1 you have taken? x1 y1. What are the coordinates of m2 you have taken? x2 y2. But you can clearly see that x2 y2 is a point, and this mass has taken so much of the space. So unless and until you will make this mass as a point, you will not get the exact location of the center of mass. Can you understand this point? You are taking the coordinates z2, okay, x1, y1, z1, x2, y2, z2. So this is a point, but here delta m you are taking it has some definite shape. So unless and until you will divide this extended body into point masses, you will not get the exact answer. So that is why I'm dividing it into point masses. So I need to make n bigger and bigger. How much bigger? Means n approaches to infinity. Approaches means keep on moving, and towards bigger and bigger. So there are two ways of writing the same thing. One is make n bigger and bigger, and second way is n approaches to infinity. So that is the same thing. So students, whenever there is any mathematical notation, you must know how to write it. So how do you write if you need to write it? If you want to write it in written expression. So this is mathematical. So n tends to infinity means make n bigger and bigger. Bigger and bigger. And the second thing is when n will become bigger and bigger, what was your purpose? Why you are making n bigger and bigger? So that this delta m becomes smaller and smaller. Yes? That was your purpose. So each delta mi becomes smaller and smaller. Smaller and smaller. Now how to write this thing mathematically? Mi smaller and smaller. So you can write it as delta mi approaches to 0. So its size is approaching to 0. Here the number is, so when you increase this, then only they will become the point masses. Okay. So these are the two things, 1 and 2, that you are going to do. Students, I hope this is clear. And
yes.
Okay.
Yes, sir.
Good. Now.
Yes, sir.
Okay. Now, what delta? So you have here delta mi, right? So how do we write this expression, this delta mi? What this will become when this will be infinity and this thing, right? So what this delta mi will become? So sigma delta mi, how you will write it when you are finding the sum of all the masses and their point masses, and their number is infinity. So when the number is infinity, when n is infinity, and this delta m tends to this delta m becomes smaller and smaller. So when you are finding the sum of infinite terms, okay, so instead of summation you need to put this integral sign. So integral sign nothing but summation of adding infinite values. So what is the meaning of this summation? Adding infinite values. Okay, so this is what does this mean. I hope this is clear. Okay, so instead of writing summation n tends to infinity, just simply write this thing. Okay, and the second thing is, so this is a different notation. Thing is the same, adding all the masses, but here when the infinity, when there is finite and discrete, we use this summation, but when there is continuous and infinite, we use integral sign. Okay, so meaning the same. Now this delta sign will change into d, and this is dmi. So this is very simple thing, students. Okay, and so what was this value? This value was of course, like you were writing delta mi zi upon, what was this value? This capital M. So this also means capital M, this also. So mass will remain the same, mass of the body will remain the same, but these are the two ways of writing. Even you write it like this. So is the mass going to change if you write it in different way? No. Okay, this is how you are going to write the mass. So this thing is clear. Okay, when there is infinite values we are taking. Okay, now how you are going to write the other things like this thing. So this thing you have understood. You can write it as This thing you can write it as equals to capital M. Okay, fine. Now how you are going to write this sigma delta mi xi? How you are going to write it when when n tends to infinity, and this delta mi will become smaller and smaller. So this delta mi into xi, and here this n tends to infinity, and delta mi tends to 0. So how you are going to write this whole thing? How you will be writing it?
With integrations.
Yes, with integration sign. Okay. So mathematically, instead of writing these three things, let us write one simple integral sign. And the next thing is, I told you this delta sign will change to d. Okay. So this is d mi. Now the next thing is you have xi. So students, what was the meaning of xi? So suppose this was m1. So xi was distance from the origin on the x-axis, right? This was xi. Yes or no?
Yes.
Yes.
Okay. Similarly, let this dmi is at x distance. So suppose this was somewhere your this dmi, and dmi is at a distance x. So instead of xi, we'll take it in the general term that this is at a distance x. Okay, because we have pointed out a particular means mass. Okay, it can be any mass, but it will be at a particular distance from the origin. Okay, so instead of xi, I will write as x. Is this clear, students? So these are the two changes, and this d thing we write at the end, and all the things in the beginning. So this is I can write it as, and now there will be no I thing. Okay, there will be no I thing here. So this there will be no I thing here also. So you need not to write I, because this so there's no I thing. I will not be there. So simply you are adding all the small masses dm. Okay, adding all the small masses here also. So in the summation you need to tell that n is equal to 1 to infinity, but here you need not to tell anything because you are adding everything. Okay, so no need to. So that's the difference, students. Here there is I you are writing, but here there will be no I. Okay,
Why, sir?
why? Because that's a good question. See, I'm telling you that this is the mass dm you are taking here. So how much is this dm distance? Its coordinates will be, suppose, x, y. Okay, so how much is it distance? So x, y, z also, suppose 3d. Okay, so this distance is x, this distance is y. So we'll take all the points in the similar manner. Okay, like one small mass, another, and its distance from the on the x-axis means x coordinate, its y coordinate. So see, these are the ways of writing the things. Because here, why I was writing I? Because that's a very good question. I was writing I because, see, how do I write it? I will write it as, put x I range from I is equals to 0 to n, suppose. So I will be replacing I with 1. So delta m1, and this I with 1 plus, now I is equal to 2. So this is the meaning of summation. Put I is equal to 1 and then add, and put I is equals to 2 and then add, put I equals to 3 and then add. So that was the purpose of adding it, and keep on adding it till delta m n and xn. So I had finite values. So I was replacing I with 1 and then replacing I with 2 and then replacing I with 3 and then replacing so on and replacing I with n. But here these values are infinite. You cannot write it in this way. So we used I because I was replaced with 1, 2, 3 and so on. But here, as these values are infinite, so I need not to write it in this way. So that is why I is not needed. So it is any, so like here it was any mass, okay, mi, arbitrary. So whenever I is there, I told you it can be any particle, arbitrary particle, arbit, ray. So arbitrary means any particle you can take, it doesn't matter. So here also you have taken small, this very important point you have raised. So this is the small mass dm and its coordinates are xyz. So keep on adding the small mass and its coordinates, small mass and its coordinates, smaller mass and its coordinates. So smaller mass, small mass and its coordinate from the x-axis. So this mass and coordinates from the next mass and its coordinate from the x-axis, next mass and its coordinate from the x-axis. Is this clear? We'll do it today. So that's how this will be replaced with. Now similarly this delta miyi will be changed to you can see in your books also. So this will be changed to ydm. Okay, so similarly sigma m delta mi yi will be replaced with, tell me what it is replaced with. Delta will come at the end, so this dm, remove the negative sign, remove the I symbol from the subscript, and then y. Okay, and sigma delta mizi will be replaced with z dm. Is this concept clear, students?
Excuse me, sir.
Yes.
So here you have said that we use integral sign when there is continuous.
When there is
continuous.
Yes.
Continuous. Then
Everywhere
what does
in
it
physics,
mean?
yes. Whenever there is continuity.
Yes,
Okay.
sir. Then what does it mean? That what the continuity means?
What is continuity means? Okay. Like, that's a very good question. See, you have the number line. So you have integers 1, 2, 3, 4. And when this is, so this is integer line, okay? Now you have real number line. So real number are continuous. Okay? So it can be means 0.223, 1 point, and you know that there are infinite numbers between 1 and 2. So that is the meaning of continuous. Okay, so continuous means like there is no gap. There is no gap. Numbers are together. Here there is a gap. So when you make a graph, suppose, so this point, this point, this point. So these are discrete. But if you draw a line, then the points are continuous on this line. There is no discontinuity. Here there is discontinuity. There is no mass in between. There is no mass in between. But here there is a particle between the two particles. Okay. So particles are together. There is no space between them. So continuity means there is no space between the mass. But here you can say there is space between the mass. Okay.
Yes, sir.
So as there is continuity, so there will be of course there are we can calculate the number of atoms and molecules, but still the number is so large that you are ignoring. These discussions are very, very important. It seems easy that the question is so simple, so easy. Some students will think, why has she asked this question? But let me tell you, these questions are very important, very important. Okay, so like here I have, I can calculate the number of atoms and molecules in this body. There's no doubt about it. I have the formula. I know the molar mass and everything. Okay, I know the concept. But the point is that here the number of atoms are so, like 10 raised to the power 24, 10 raised to the power 23. Even if you remove 1 or 2 atoms, will it going to affect the number? How you are going to write it? You are going to write it 6.123 into 10 raised to the power 23. So I suppose remove 10 atoms from it. So will the number change? No, because it will remain 6.123 into 10 to the power 23. Have you understood it, students? If you remove,
Yes, sir.
even if you remove 1 million atoms, still there is no impact on the number of atoms, because the number that you are removing is negligible. Okay, so here the grainy nature of the atoms is no more, and it has become, so this grainy nature, okay, this grainy nature is no more. Grain nature means you have one grain over here and one grain over here and one grain over here, and now you have made a chapati. You have grinded these means grains, and now you have the flour. So flour is continuous, the grains were discrete, okay, but now the flour that you get is continuous. Chapati is continuous, so the grainy nature is lost. So when the number is so much, the grainy nature is lost. That again the discussion that will be there in the first chapter of the 12th class. So this grainy nature is lost, and it becomes like a continuous. There we will study it in terms of charge. Here we are studying it in terms of mass. So that discussion was very important. Have you understood this concept, students?
Yes, sir.
Yes, sir.
Okay. Now that's good. So now, students, how will I write this x means this x? You have replaced this x with x dm, and you replace this mass with sigma dm. So these are the two formulas that you have now. So this formula when you have discrete masses, and this formula when you have continuous mass. Is this clear? So how we have changed this formula to this formula? So here the delta m mass was at the position xi distance. Now these are infinite, so continuous masses. So one mass is dm, and the location of that dm is x. On the x-axis it is x, and on the y-axis, similarly you can write it for y-axis. So that will be equals to. So let me remove this. So on the y-axis it will be, so this will be equals to sigma. So students, this delta will be changed to d, and remove the I sign, and this yi will change to y. Remove the y sign. And similarly here this delta will change to this summation will change to integration sign. This delta will change to d, and this I will be removed. Have you learned this now? Okay, let us repeat with me. This summation is going to replace with integral sign. Very good. This delta will change with
D.
and write it at the end. Okay, and this I will further be removed. Okay, now what about zi?
Z.
And this this here summation will be replaced with summation delta integral, and this delta will be replaced with
DM.
this is also delta. See, we have three ways to write the delta. One is this delta, second is this is also delta, and this is also delta. So we have three deltas in the maths, in the physics maths. Okay, so all of them means infinitesimally small. Okay, so this will be dm. So students, this is these are the only two simple things. So you can always write in this way. First write this way, you will never get confused. Okay, write mixi upon delta mi, and then write this formula in continuous form. Okay, is this clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
See, that's why I keep on telling the students that attend my class every day. There's lots and lots of revision in my class. So even if you have not understood it one day, next day you will be able to understand it. The important thing is that you need to attend my class every day. You cannot afford to skip any of my classes. So now, I hope you people are comfortable with example 7.1, 7.3 and the questions with the discrete masses. if you have means you can see the yesterday's video also, last video. Okay, so today we will do the means continuous mass we are going to take. So we are going to find the center of mass of a rod. Center of mass of a rod. So this is the this is my rod. Okay, so this is origin, and let me write the formula first of all. Center of mass, so this is one dimension only, there is no y, only one dimension, x. So what is x equals to sigma? If it is discrete, then sigma mi xi divided by sigma mi, right? So if it is discrete form, discrete masses, how will you write it for continuous mass now? Yes, students, this summation will be changed to, come on, integral sign. Very good. This so this was so we had delta mi, right? So yes, small masses. Okay, so xi cannot be small like delta xi. No, this is small, masses were small. So this delta will change to d, and I will be removed, so dm, and write it at the end. And what is this xi? It will become a x. So simply you need to do simply 3 steps. One, instead of summation, because there are delta m has become is tending to 0 and the number of particles tending to infinity, so that is why we are putting an integral sign. And first thing you need to do is, so students, write it in this way only, change this with this. Second thing is, this delta is replaced with dm. This is the second thing you need to do. And the third thing you need to do is that remove the I. Okay, so these simple 3 steps. Is it okay?
Yes.
Okay.
Yes, sir.
And now remove this summation sign with
Yes, sir.
integral sign, this delta with d, and this remove the I. You will get m. Any problems?
No, sir.
Sir.
Okay, good.
No,
Now
sir.
students, I have told you one thing, where this delta m is the small mass. So let us consider the small mass here. This is dm. Is this okay? What is this x? So here the delta mi was at a distance xi. So here this small mass I am considering is at a distance, how much distance? Is at a distance x. It's so simple. Is this okay? Now there
Yes,
will
sir.
be definitely other mass also, and at different distances from the x. So I am going to add all of them. Okay, I'm going to add all of them, all the infinite dms. Is this okay? So now how to add them, this is what we need to learn. We have understood the meaning of x dm. Have you understood?
Excuse me, sir.
Yes.
सर जैसे यहाँ पे डिफरेंट डिस्टेंसेस पे डिफरेंट स्मॉल मासेज होंगे,
हाँ.
लेकिन हमने इंटीग्रेशन में तो सिर्फ एक्स ही डिस्टेंस के ले लिया है डीएम को.
No. Integration means, what does this mean? Adding infinite mass elements, means this infinite x dm combination. You are adding this infinite x dm combination. This is what does this mean? All the
Okay.
x dm combinations you are adding. Like here, you had suppose mass m1, m2, m3. So the formula for that was, so this at distance xi, this distance x2, and this x3. So you were finding the center of mass. Obviously it will lie on this line also, somewhere here suppose. So this x was equals to sigma mi xi upon sigma mi, and that was equals to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. But now here you have this small dm and it is at a distance x. So again there will be another mass and it will again be at some distance from x. So instead of writing them separately, now you are writing them x dm, means take any element dm which is at a distance x and add all of them. So we are going to add all of them, okay, and divided by sum of all the masses. So here also we are doing the same thing, but here they are infinite. So I'm not pointing because here I can replace I with 1, 2 and 3 because, and if even if there are n suppose, so I can write it, replace it with mn xn. But here n tends to infinity, so I can write here 1, 2, 3, 4 because this is continuous. So okay, so same thing I am doing here xm. So this is another mass and it is at this distance suppose. So I am going to multiply this distance with this mass. So distance mass, 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 all of them I am adding, and this is the way. So what does this mean? Adding mass, small mass, and it's adding the, what you are doing? You are adding, what you are adding? What you are adding? So this means adding, okay. This integral sign means what you are adding? Products of small masses, infinitesimally small mass, infinitesimally small mass, and small mass and its distance on x-axis from origin. So that's your choice, whether you want to write it this way mathematically, integrating xmi, this product, or write it like this. So this is what does it mean? Adding the product of infinite small mass and its distance on the axis from the origin. So what you are doing? You are adding, this is the first small mass and its distance from the origin, multiplying both of them, plus next small mass and its distance from the origin, and this small mass and distance from the origin. This is what you were doing here, mass and its distance from the origin. You were here also, you were adding the products. Here also you were adding the products. So here also I am adding the products, but there are two different ways of writing it. Notation will be different. Is the concept clear?
Yes, sir.
So here also again next mass and its distance from the origin, next mass, distance from the origin, okay, this way. Is this clear? So very important concept, very important. This discussion should be, means I like this discussion. Students should discuss it. Unless and until you discuss it, you won't be able to understand. So next mass, next distance, next mass, next distance. This is what this simple, that's the beauty of mathematics and physics also. So writing all this thing in very simple way. Okay students, I hope you have understood it. Now let us find this. So this was the note in the middle. Okay, now this x dm, this x is equals to what is, how you are going to write x dm. Okay, so in all the questions that you people will be doing, so what is this see, this center of mass of the rod, this integral dm means, of course, it is equals to m. So x dm upon sigma dm. So what is this? What is the mass of this small dm? So mass of this small dm is, I can multiply this with the, see, we have we have densities. See, you have studied a lot of density in part 2 also, but the important densities are three important densities: mass density, number density, and charge density. So mass density means mass upon. So now mass density, number density, charge density. So these are also of three types. Okay, mass density, linear mass density. Like here, it is along a line one dimension. So linear mass one dimension. When you have two dimension, then you have means or three dimension. You can write it as so here the symbol of linear density is lambda, and when you have mass density for 2D means for 3D, of course it will have mass only for 3D, so then the density will be rho. So these are the two things. In case of charge, we have three symbols: for linear mass density, for surface charge density, and for volume charge density. And for number, we have only one symbol, that is number density. We write it with small n, and that is equals to number upon volume. So these are three parameter: density, mass density, number density, charge density. And but here we are using, so what kind of density with mass density it will have? Linear mass density, because this is we are only considering the length of the rod. Is this clear?
Yes, sir.
So linear mass density is lambda. So linear mass density is equals to, its symbol is lambda. So lambda is equals to mass upon, and linear means only line is there, only length is there. So lambda is equals to m by L. Okay? So this is the density. So when you are finding mass, like mass of dm, you are simply multiplying the density. I will be writing as density, and this is, suppose this length is dx. What is this length? Dx. Okay? So this will be equals to, dm is equals to this length into the mass, linear mass density. So lambda dx. Isn't it? So density is equals to mass upon volume. So here you are writing mass. Okay? So mass is equals to density into length. See, this is the same formula you have used here, students. What is mass equals to? Mass equals to lambda L. Isn't it? Lambda is equal to m upon L. What is m equals to? Lambda into L. In case of simple density, density is equal to mass upon volume. So what is mass equals to? Density upon volume. Yes? Students, you have studied so many chapters of chemistry. You have studied part 2 physics 11th class. What's the problem with this density? Density is equal to mass upon volume. So what is mass equals to? Density into volume. So here mass equals to, when the mass is so small, dm is equals to density into length. Is this okay?
हाँ sir.
Yes, sir.
So
Yes, sir.
Yes.
okay, now it shows the confidence. Good. So now this you are going to replace this. This is what you need to do in all the questions. So x into dm is equals to lambda dx. Okay, and divided by this this is the total mass, right? And this equals to, now students, here there were no limits, okay, but here we have the limits. We have finally reached dx. So dx has the limit. So dx vary. This dx, from where you need to add, right from here to here. Add all these dx, 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 all these dx you need to add. Is this okay? So from where you need to add? You need to start from 0 and up to the length L of the rod. So all the dx you are adding. कहाँ से कहाँ तक ऐड करेंगे आप dx को? 0 से लेके L तक जितने dx बनेंगे, सारे dx को ऐड करेंगे. तो ये जो लिमिट्स आती हैं किसके अकॉर्डिंग आती हैं, किसको ऐड करना आपको, dx dx dx, ये सारे dx, सारे स्मॉल dx 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 ये आप ऐड करेंगे. इज दिस क्लियर टू एवरीवन?
Yes, sir.
So all
Yes, sir.
yes 0 to L. So this is lower limit from where you are going to start, and this is the upper limit where you are going to end. So you have to add all the dx between the length 0 to L. Now this equals to, so all the constants, so delta lambda is constant, so we have this linear mass density is constant in this case. Tomorrow we will do a case where this linear mass density is not constant, it is variable, but today we are doing constant. Okay, so this lambda upon m, and what will remain in the integral sign, x dx 0 to L. So what is the integration? I told you that integration is simply what you need to do, you need to add 1 to the power, so power was 1, so 1 plus 1 and divided by this 1 plus 1, okay, and limit 0 to L. So that's equals to lambda upon m and x upon 2 divided by 2, 0 to L. Now this will be equals to, what this will be equals to, so I am finding the center of mass x coordinate, so lambda upon m into, put x equals to L, put x equals to L, so L square upon 2, upper limit minus lower limit, so put x equals to 0, so 0 square upon 2, and this will comes out to be lambda upon m into L square by 2, isn't it? Now what is lambda equals to? Lambda equals to m by L, so put the value of lambda, so lambda equals to m by L into 1 by m into L square by 2. So this m will cancel out, 1 L will also cancel out, and you get the answer L by 2. So center of mass of this rod lies at the distance L by 2 from the origin, and that is the midpoint, isn't it? So what is the center of mass? It is at a distance x, which is equals to, so x is equals to L by 2, so that is the center of mass. I hope this is clear, students. And there is another way you can discuss that center of mass, like if there is any dm on the x side, there will be another on the minus x side. You can discuss it like this. Another way of writing L by 2, suppose this way, when you are moving this side, this is minus x, when you are moving this side, you will be plus x, okay, so you will have same mass here dm, you will have same mass here dm. So adding the distances with masses, so here you are adding minus x dm and you are adding plus x dm, so minus x dm plus x dm cancel out, so all will be cancelling out, and you will be in the middle, L by 2. So that discussion is there in your NCERT, you can read it from there. So one was this means analytical approach, and that was discussion approach that is there, okay. Any doubts, students, in it?
No, sir.
Okay,
No, sir.
No, sir.
okay, so every day we will have the same routine. Please tell it to your friends how important and how easy it is to understand the physics